Okay, for this second part of the video, we are looking at Chapter 12, Worksheet 1 on Statistical Data Handling. Okay, previously we looked at the frequency diagrams, which we have gone through over here. So today we're going to look at the next part, which is on pictograms as well as bar charts. Alright, so you will have seen pictograms in primary school before. We use figures or any kind of pictures to represent any form of category. And usually a legend will be included to show that the number represented by each image that we use. Okay, and remember that the number is only proportional to the frequency, meaning that the more shapes there are, the more number is it. Okay, the size does not tell us how many there are. So you can see over here, this is a pictogram. The number of pairs tell us how many children chose this shape. The size doesn't tell us how many. So let's say I have over here 1, 2, 3, 4, 5, 6, 7. 7 pairs, and the diagram says each figure represents 10 children. I have total 70 children that chose pears, and only 10 children that chose watermelon, even though the size of the watermelon is equal to 2 times the pear. Okay, so pictograms are what you have seen before. Okay, I think you have learned this in primary school, so this is just a very simple recap. Okay, characteristics of pictogram: we must have a heading to tell us what exactly this pictogram is about. A legend must be shown to show that one picture represents how many items. Like you can see this cupcake over here. Okay, and a fractional part represents a proportion. So let's say if one cupcake over here represents 6 cupcake. Okay, you can see over here, one cupcake represents 6 cupcake. Half a cupcake will therefore represent 3 cupcakes. Alright, so I give you maybe 1-2 minutes. Can you think about what are the advantage and disadvantage of using a pictogram? Okay, pause this video. Think about spend 1-2 minutes, think about it, write it down before continue playing this video to go through this advantage and disadvantage. Alright, okay, so now I'll go through this part over here. Advantage of pictogram is very simple. It is very easy to read because all you need to do is to look at the pictures to count. Okay, and also to any viewer that looks at this diagram, you can see that and it is also very visually appealing. What does visually appealing mean? It means that it's very easy for anyone to read and understand the diagram, because the diagram uses, you see, like let's say if I have cupcakes, I use cupcakes to represent it. If I have fruits, I use the fruits to represent the data, which is very nice for anyone to read the diagram. Okay. But some disadvantage of this is that, let's say if over here, one cupcake represents 6 cupcake. What if I have one cupcake only? How do I cut this cupcake into 6 parts? It is a bit difficult. So therefore, the disadvantage over here is that, write out, it is hard to quantify a partial figure. So let's say if I have only like one cupcake in this case, it's very hard to cut this cupcake into 6 parts. So over here, as a result, okay, degree of accuracy, meaning that when I read this diagram, can I straight away tell what is the number? It is not easy. So the degree of accuracy of the figures, of the shapes that we use, is low. Okay, so these are some of the advantage and disadvantage of using a pictogram. So let's answer some very simple questions. From figure 1a, what is the most popular fruit among the children? Let's go back to figure 1a. So they tell you that each figure represents 10 children. So I hope you can see very clearly in this diagram here, which one do you think is the most popular fruit? And I hope you can see it's the pear, because there are so many pears. There is 7 pears. The rest of the other fruits only have 1 figure. Okay, so over here, very simply, figure 1a, the most popular fruit is simply the pear. Okay. And for figure 1b, how many more cupcakes were sold on Sunday than on Wednesday? So let's go back to the diagram on the cupcakes. Sunday. Okay, let's go and count. Sunday, how many cupcakes do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 9.5. 9.5. And since each cupcake is represents 6 cupcakes, so over here I will have how many cupcakes? I will take 9.5 times 6, and this will give me, okay, 9.5 times 6, this will give me 57 cupcakes. This is the number sold on Sunday. And on Wednesday, I have 1, 2, 3, 4. So Wednesday, I have a total of 4 times 6, which is 24 cupcakes. So if I were to compare Sunday and Wednesday, how many more cupcakes? It would be 57 minus away 24. Okay, 57 minus, 24, which is equal to 33 more cupcakes sold on Sunday than on Wednesday. Okay, this is for the pictogram question. Alright, let's now look at page number 6. A survey is conducted among a group of students who travel to school either by bus or by car. So we can look at this diagram over here. They say that, there are 3 buses, okay, whereas for car there are 4 cars. So let's look at these 2 students' claim. Li Xin claimed that more students travel to school by bus because the length of each bus is longer. But Michael claims, no, more students travel to school by car because there are more cars. Who do you think is correct? Li Xin or Michael? Okay, I give you 1 minute. Think about it. Think about what we have gone through previously and think about what is the correct answer. Who is correct? Once you're confident, pause this video first. Once you're confident, then press play to see the answer. Okay, so I hope you have thought about this question over here. So actually, if you remember what we have gone through, the correct person is actually Michael. Why is Michael correct? Like what we have gone through earlier, the number of figures is proportional to the frequency, not the size. So that means in this diagram over here, if I have 3 buses and 4 cars, one figure usually represent, let's say, maybe 10 children. Even though the bus here look longer, in total I should only have 30 children, while car have 40 because bus have 3 figures, cars have 4 figures. So even though the bus look longer, actually there are more students that travel to school by car. Alright, so how can we modify this pictogram to avoid misinterpretation? To make it clearer, how can we make this diagram clearer? So what you can do is that, see this bus here, the bus shouldn't be so long. The bus should be the same size as the car. So when I draw the bus, it will be 1, 2, 3. It will be much clearer that the car is definitely more students actually travel to school by car. So how can I modify this diagram? Alright, okay. Draw the bus to be same size as the car, or you can also make the car same size as the bus. Then you have 1, 2, 3, 4 cars like that. Okay, up to you. You can either make the bus smaller or make the car bigger. Okay, but all these figures must be the same size. Alright, let's now go to example number 4. Okay, I have a pictogram here that shows the profit earned by a company from 2014 to 2019. Each bag of money here represents $1 million. What is the profit earned by the company in 2017? So let's look at 2017 here. Okay, how many bags of money do I have? Let's count. I have 1, 2, 3, 4, 5. This is half a bag, so it's 5.5. Okay, one bag represents $1 million. So over here, this means that 2017 is 5.5 bags times $1 million per bag. Answer for this question should be 5,500,000. So answer for this question is $5,500,000. Okay. Likewise for 2019, I look at 2019, I count the number of bags. 1, 2, 3, 4, 5, 6, 7. So over here, I have 7 bags times $1 million each. Total, it should be $7 million. Okay, so over here, this is $7 million. Okay. Moving on. In which year did the company earn the least profit? So if I were to look at this diagram here, The least means the lowest number. If I compare everything, you based on the number of length, you can see that actually the shortest length would be 2016. Because 2016 is the shortest. So if I look at 2016 over here, okay, what is the profit? How much did the profit decrease that year compared to the previous year? So the previous year was 2015. Then 2016 became the least profit. So let's count very simply. How much less? The profit decreased by this amount here. 1.5 bags. I know that 1.5 bags means 1.5 times $1 million each. Okay, the profit decreased from 2015 to 2016 by $1,500,000. Okay, so over here, you can say that 2016 earned the least profit. Okay, oops, let me write it clearly. Okay, profit decrease by $1,500,000. Okay, this is for example number 4. Okay. Alright, so this is the last example on pictograms. So I hope that through this question here you have understood how do we analyze pictogram questions. Okay, let's now look at the next one, which is on bar charts. Okay, on page number 7. Okay, I'm sure you have also seen bar charts in primary school. Okay, these should not be unfamiliar to you. So bar charts are used to represent the length of the bar tells us how many number of units or the frequency of the different data that we are analyzing. So bar charts can look in so many different forms. You can see on this diagram here, there are so many different ways to draw bar charts for people to analyze. Okay, so using these diagrams over here, can we also spend maybe about 1 minute? Think about what are the advantage and disadvantage of using bar charts to represent data. As you know, for bar charts, we always have a heading very clearly. We must know what are the axes labeled. Okay, the bars must be the same width, and there must be space so that you can easily see each category. What is the frequency? Okay, so spend about 1-2 minutes before and pause this video. Once you have thought about the advantage and disadvantage, then you can press play to go through this the advantage and disadvantage of using a bar chart. Okay, alright, let's continue on. So I hope we have thought through this question here. Advantage, very simply, advantage, bar charts are easy to draw. All you need to do is draw rectangle boxes to represent the bars. So easy to draw. And it's also very easy to read and compare differences. Okay. But the disadvantage of using a bar chart in this case is that sometimes you can only see, let's say, very distinct numbers like how many people are late to class, the revenue in dollars. Okay, but you cannot easily see what is the percentage of one group over the other. So in this case over here, okay, this analysis cannot easily show percentage of each class. Okay, so as we do more questions, you realize how the different characteristics of each different statistical diagram. Alright, so going back to some of the big ideas we have learned. Okay, diagrams. In this case over here, bar charts are a very easy way for us to represent data because the length of the bar chart is proportional. Proportional meaning that the longer the bar chart is, the higher the number of frequency it represents. Okay, so let's now look at page 8, example number 5. Okay, I'm given a bar chart over here. Okay, shows the number of cars of different colors sold in 1 year in the city. Which is the least popular color? I hope you can see very clearly from this diagram. So this is number of cars. This is blue, gray, white, red, black. Which one do you think is the least popular color? This axis tells us, the vertical tells us the number of cars in thousands. Okay, I hope we can very easily see that since black is the shortest bar, it is obviously the least popular. Okay, the least popular is black. Okay, and the next part over here, Shufen says there's a mistake in the bar graph because grey car, if I look at the number on grey over here, okay, grey 3.5 only, and she say black car 1.5, so there cannot be 3.5 car and 1.5 car in real life. Do you agree with her? Spend 1 minute, think about it. Is she right? Can there be 3.5 cars? Okay, think about it. Once you have thought about it, continue watching this video to understand whether she is correct or wrong. Okay, alright, let's answer this question over here. I hope we have thought about it already. Okay, so the answer is actually, do you agree with her? No. Okay, Shu Fen is incorrect. But why is she incorrect? It goes back to this bar graph over here. You look at the axis here, right? This is the number of cars in thousands. So if I see 3.5 car, does it mean 3.5 in real life? No. It actually means 3.5 thousand. Okay, so over here, we will write, the reason for this is because 3.5 grey car represents 3.5 thousand. Okay, which means that this is 3.5 times 1000. Actually, this means 3,500 grey cars. It doesn't just mean 3.5 grey cars, but actually 3.5 means 3,500 grey cars. Likewise, over here, the black car, 1.5 grey car, not black grey car, sorry, 1.5 black car represents 1.5 thousand. Okay, and then this is over here, 1.5 thousand times 1000. This means I have 1,500 black car. Okay, alright, this is for example number 5. Okay, alright, let's now look at the last example for the use of bar graphs over here, example number 6 on page 9. Okay, can I get you to go and try by yourself first? Okay, complete the bar graph using the data given in the table here. So I'm in this question here, I have sales of television sets in 7 shops. Each there's the blue color bar represent November, purple color bar represent December. Okay, so using this data here, go and complete the data in this table. Okay, I give you maybe about, can you pause this video first, spend about 5 minutes, try all the questions here before you continue playing this video to understand and go through these different questions. Okay. Alright, so now I will continue going through this question over here. Okay, over here I have a bar graph given in this table. So I look at shop number 6, 64 and 88. So that means first I will draw a blue color box for 64. 64 will be up to about here. Okay, remember each unit represents 4 units. Okay, I hope you can see. 20 is represent 5 lines. So over here, each number represent 4, 8, 12, 16, and 20. So each small division represents 4 television sets. Okay, so over here 64 should look something like this. Okay. Okay, and I'll cut. Okay, this is 64. Then purple I use red lah. December is 88. I will draw 88 over here. Okay. Okay, can. Yeah, so for shop number 6, you should look something like this. Okay. Then for shop number 7, likewise, same thing. 70 means somewhere in the middle between 60 and 80, which is about here. Okay. Then shop 7, 96. It should look something like this. 96. Okay. Dear, oops. Okay, this is shop number 7. Alright, so you should see about these two diagrams over here for example 6 part 1. Alright, so now moving on from here, find the total number of television sets sold in the 7 shops in November and December. So total number very simply over here. November means I want to add up for each shop, the blue color bar. I read out all the numbers over here. I add up to find the total number of television sets sold in November. So I read my diagram over here. Maybe I write out so it's very clear on my diagram. Okay. Shop 1, November I have 60. Shop 2, November I have 20, I have 30 over here. Shop 3, I have 50. Shop 4, I have 70. Shop 5, I have 40. Shop 6, I know is 64 and 70 from part 1. Okay, so I can now write for November, answer is equal to 60 plus 30 plus 50 plus 70 plus 40 plus 64 plus 70. Okay, answer should be equals to 384. Okay, likewise for December, I look at the purple graph and I write on the diagram so it's very clear. Shop 1 I have, let me make it a bit smaller. Okay, shop 1 I have 90. Shop 2 I have 48. Shop 3 I have 80. Shop 4 I have 112. Shop 5 I have 80. Shop 6 and 7 is provided in part 1. So over here this is, we write over here 90 plus 48 plus 80 plus 112 plus 80 plus 88 plus 96. You calculate out everything, you should get 594. Okay, this is for part 2. Okay, for part 3, express the total number of television sets sold in the 7 shops in November as a percentage of the total number of television sets sold in November and December. So I know that over here, total number of television sets sold in November is 384. November and December is I have to add them up together. So over here, this question is asking me to find 384 out of the total number of television sets sold in November and December, which is 384 plus 594. And as a percentage, so I'll times 100%. I calculate in my calculator, press it by yourself, you should get 39.3%, round off to 3 SF. Okay, this is for part 3 over here. Alright. Okay, so moving on from here for part 4, express the total number of television sets sold in shop 7 in November and December as the percentage of the total number of television sets sold in the 7 shops in November and December. So if I look at shop 7 in November and December, shop 7 sold, we go at shop 7, shop 7 November and December sold 70 and 96. So this is 70 plus 96 out of, as a percentage of the total number of television sets sold in the 7 shops in November and December. In that case over here, the total number in this sold in November and December would be 384 plus 594. Okay, 384 plus 594, and I times 100% to find the percentage. Okay, answer to this question should be 17.9%, round off to 3 SF. Okay. Alright, and for the next part over here, okay, the company would like to close down one shop due to insufficient cash flow. Based on the number of television sets sold in November and December, the manager proposed to close down shop number 7. Do you agree with the manager? So let's look at the bar graph over here. Okay, the manager say, because of they want to close down one shop. The manager proposed I should close down shop number 7 based on the number of television sets sold in November and December. Do you agree? All you need to do is look at this diagram over here and analyze. Is shop 7 the worst performing shop when they sell television sets? And you realize that, no, there are other shops that sold less than shop 7. Which other shops? You can see very clearly over here. Shop 2 is actually selling the least number of television sets compared to all the other shops over here. So over here, very simply, to answer the question, do you agree with the manager? You can say that no. Okay. Shop 2 sold fewer television sets in November and December than shop 7. Okay, and this is the answer for part B over here. Okay. And for the last question over here, in which month did the company perform better in terms of sale? So you compare November and December, okay, you can see very clearly. Okay, November, I sold a total of 384 television sets. In December, I sold a total of 594 television sets over here. Which month did the company perform better? So obviously, the answer should be December because they sold more television sets in December than November. Okay, so over here for this question, okay, company perform better in December. Why? Because all shops sold more television sets, which is December I sold 594. In December than November. Then you can give data to justify. November I only have 384. November I only have 384 television sets sold. Okay, and this is all for this part of the worksheet. Okay, once you're done, I'd like you to go and do your workbook question 1, 2, 3, and question 6 over here. Okay, so this will help you consolidate whatever we have gone through in this worksheet over here. Okay, workbook question 1, 3, 2, and 6. Once you're done with this part of the worksheet. Okay, alright, and that's the end of this part of this video.